Alright, this is 11.5, homework number 2. We're still solving rational equations. So a rational equation is still an equation that contains one or more rational expressions. So let's jump right into the examples. Now, on these examples, we're going to be looking at denominators that are binomials or have binomials in them. So this binomial is 9c, parentheses c plus 2. This binomial is c plus 2. We don't have to worry about the denominator that has a 1 because it's already the way we want it. So 9 parentheses c plus 2 is already factored. It's still 9 times c plus 2. C plus 2 is just c plus 2. So they have in common a c plus 2. They don't have in common a 9. So our LCM is 9 parentheses c plus 2. So we're going to put that in each numerator. We have a 9 and we have c plus 2. We have a 9 and we have c plus 2. We have a 9 and we have c plus 2. Alright, so just like with the other ones, we're going to now reduce. Don't multiply 2 and 9 together. It's not going to help you any more than making the more work. So 9 and the 9 divide out and become 1s. C plus 2 is c plus 2. Divide out and become 1s. So we're multiplying 2 times 1 times 1. So this first fraction, once we multiply by the LCM, is just 2. Now the next fraction, we already have 1s. So we're multiplying 1 times 9, which is 9, and then doing the distributive property for 9 and c plus 2. So that's 9c plus 18. On the last one, we're dividing out the c plus 2's. So now we're multiplying 2c times 9 times 1, which is 18c. Okay, so on the left side, I have like terms. So I'm going to add those together. And now I'm going to move my 9c to the side that already has just a c and divide by 9. Now, do not divide this by 9 in your calculator. Just leave it 20 over 9. And 20 over 9 does not make either denominator 0. So we're good. Okay. Next one, we have 2 different binomials in the denominator, and the 1, of course, but we're not looking at that one. So our LCM is the 2 different denominators. Multiply together, but don't do FOIL. So I'm going to have r plus 1, r minus 2 in this numerator, r plus 1, r minus 2 in this numerator, r plus 1, r minus 2 in this numerator. Alright, so r plus 1's cancel, so they become 1's. So I'm multiplying 6r times r minus 2. So that is 6r squared minus 12r. Now, next one, r minus 2's cancel. So I am multiplying 3 times r plus 1. Doing the distributive property again, that's 3r plus 3 equals. Now, over here, I already have a 1 in the denominator. So, I don't have to do any canceling. I'm not dividing out anything. I am, though, going to first do FOIL. So, I'm going to FOIL this. And that is r squared. Let me put that somewhere else. It doesn't look like I'm putting in the denominator. Alright, that is r squared minus r minus 2. Now I'm going to multiply each term in that trinomial by 6. So that's 6r squared minus 6r minus 12. Alright, on the left side, I do have a couple of like terms, negative 12 and 3r. And on this side, I don't have any like terms. Now I notice that I have 6r squared on both sides. That's good because that means I don't have to worry about factoring. So I should just continue to solve. So my smallest r term is a negative 9r. So I'm going to add 9r to both sides. And I get 3 equals 3r minus 12. And then add 12 to both sides. So 15 equals 3r divide by 3, 5 equals r. Does that 5 make either one of my original denominators a 0? No, it does not. So the answer is 5. Okay. Number 5. So I have two binomials. But one of the binomials will factor. And that is s squared minus 36. It factors into s minus 6 plus 6. So they have in common s minus 6. They don't have in common this s plus 6. So my LCM is s minus 6, s plus 6. I don't like these s's either. Alright, so we're going to put s minus 6, s plus 6 in each, oops, not 2, in each numerator. Now remember, s squared minus 36 is actually s minus 6, s plus 6. I factored it over here. Okay, so let's look at canceling. S minus 6 cancels out s minus 6. So let's do the distributive property with the 2 and the s plus 6. So that is 2s plus 12 equals. Now, when you have a 1 for a denominator, then you don't do any canceling. Canceling. You just do FOIL in this case. So that is, I don't know why I wrote it equals. That's not equals yet. That's still plus. S squared minus 36. Now equals, there's my equal sign. Now here, s minus 6 is cancel and s plus 6 is cancel. When it cancels, it's 1, so I'm multiplying 1 times 11. Alright, now I do have an exponent that's 2 or more. So that means I need to get this equal to 0. So I'm going to subtract 11. Oops, hold on. Before I do that, let me combine like terms first and write this in standard form. So s squared plus 2s, 12 minus 36 is negative 14, equals 11. And then subtract 11. Oh, not negative 14, negative 24. Sorry about that. And we get s squared plus 2s minus 35 equals 0. And now factor s plus 7, s minus 5 equals 0. Take each factor, set it equal to 0. Solve. Check your solutions and make sure that neither solution makes the original denominators equal 0. So does negative 7 make either one of these denominators 0? Does 5? No. So both solutions work. So make sure you put a comma to separate the answers. Okay, so now let's look at a few word problems. These are called work because some work is being done in the problem. Word problems. So on these word problems, you are actually going to have to do some work. And first you need to know what the formula is for these word problems. Okay, that TOG is together, means together, over individual, plus together again over the other individual equals 1. And it will always equal 1 because it's considered to be one job that they're working on. Alright, so Smith Engineering is in the process of reviewing the salaries of their surveyors. During this review, the company found that an experienced surveyor can survey a roadbed in 7 hours. So an experienced surveyor will take 7 hours. An apprentice surveyor needs 9 hours to survey the same stretch of road. So the apprentice surveyor takes a little bit longer. If they work together, how long will it take them to complete the job? And no, it's not 8. Okay, so together is X. That's what we're looking for. So our formula is together over individual. Just pick one of them. Plus together again over the next individual. Pick the other one. Equals 1. So in this problem, the LCM is 63. So we're going to multiply by 63 in each numerator. So again, we put that 1 over 1. Okay, so reducing, 7 goes into 7 once, 7 goes into 63 9 times. 9 times x is 9x. Plus, the next one, 9 goes into 9 once, 9 goes into 63 7 times. 7 times x is 7x. Equals, now this one's already 1, so we're just multiplying 1 and 63. Alright, so 16x equals 63, divide by 16. Now, you can actually write this, keep it as 63 over 16, or make it a mixed number. You cannot make it a decimal. If you make it a mixed number, make sure you use the mixed number template. I actually prefer just putting as improper as less typing. Alright, so that is my answer. 63 over 16, or 3 and 15/16. Okay, last one. Alright, one pump fills a tank 4 times as fast as another pump. If the pumps work together, they fill the tank in 20 minutes. How long does it take for the faster pump to fill the tank? Alright, so if one pump fills the tank 4 times as fast and the other pump is 4 times as slow, okay? So the slow pump is going to be 4x. The fast pump is going to be just x. And together is 20. Okay, so when we find x, we're actually finding the faster pump's time. So if you multiply by 4, you're going to find the slower pump's time. Okay, all right, so together over the slow pump plus together over the fast pump equals 1. So the LCM is 4x. So we're multiplying each numerator by 4x. So here 4x divides by 4x and I get 1. 1 times 20 is 20. Plus here the x's cancel out. So 4 times 20 is 80. And then here it's already a 1, so I'm just multiplying 1 times 4x. So 400 equals 4x, divide by 4. In 25 minutes, this fast pump can do its job. 4 times 25 means that's 100 minutes. So that's why the slow pump is 4x. So we're wanting just the faster pump. It takes 25 minutes to fill the tank with the faster pump. All right, that is the end of 11.5 homework number 2.